Okay, Alicia, you were asking something before.
Oh yeah. I was having trouble finding the foci of the ellipse and the foci of the hyperbola.
Oh, okay.
And then from what I understand at least, one is like the square root of a squared minus b squared, and the other one's the square root of a squared plus b squared. Correct?
Yeah. Mm-hmm.
Is there a reason one's plus and one's minus, just so I can wrap my head around it?
Yeah, because for an ellipse, the focus points are actually inside the ellipse. So something. So your focus points would be inside, like here and here. So they're not as far out as the vertices. So the vertices are the bigger number of the two, whereas a hyperbola, it's flipped. So your vertices are here and here, but your focus points are further out. So the focus points are the further distance.
Oh, okay, so that's just why they're plus and minus. Okay, that makes sense. Thank you.
Another thing you could use to help you is just like the equation of the hyperbola itself and the equation of the ellipse. So for the hyperbola, you've got the minus that's in between the two fractions. So the minus changes into a plus for the hyperbola, and then for the ellipse, it does the reverse. So the plus changes into a minus. So they're always opposite.
Oh, okay, that makes sense. Thank you.
Mhm.
Oh, I had another question. It's not about the exam, but I was wondering when our last exam grades would be in Canvas.
The one where I average them,
Mm-hmm.
hopefully uh soon.
Okay.
Um, was not able to get to them because I left them on my desk over the break. So I have to go through them, but fortunately, it doesn't take too long to go through 370 exams, and our class is kind of small, so it goes even faster.
Was wondering if we were gonna have any given information, like the properties of the summations, or if there was gonna be like any information like on a given sheet, kind of like the Pythagorean properties on the last exam.
Oh, like where I gave you the identities,
Yeah.
trick things. Um, the summation properties. Oh, you mean like the formulas when you have to actually like calculate a sum?
Yeah, yeah, yeah.
Oops. Um,
I think those would be super helpful.
I
I
Definitely
do
should
as
be on
well.
there. Um, it's like, I think I can put those on there. I'm trying to think if they would even be all that useful. Um, yeah, I can stick those on there.
Okay, thank you, appreciate it.
Sure. I mean, if you don't want me to, just tell me now and I'll leave them out, but
Oh no, it would be great actually.
Yay, wonderful.
Thanks.
yeah,
Um,
okay, so I'll put the summation formulas on there.
okay, great. And then on the topic, could we actually do like a couple of summation problems?
Do you like ones where you have to calculate the sum, ones where you have to figure out if they converge or diverge? Like, do you have any? Because it's kind of
Um,
broad. So,
yeah, I think some would be best.
like calculating a sum out.
Yeah. So like or determining the sum. So like question like the 11 problems on the study guide. Number 11.
Okay. Yeah, for those, the only ones that would really use a formula would be E, F, and G.
Okay.
The other ones wouldn't need one because they're kind of small. Like A, you're only going from 1 to 6. So you could use a formula on it, but it might just be easier just to calculate it out 1 through 6. Um,
Right.
B, C, and D don't really have a formula that applies anyway.
Okay.
You are just kind of stuck plugging those numbers in.
Hmm.
Um, so do you have any in number 11 that just sort of go, let's do that one and jump out at you?
Um, could we do G?
Yeah. Okay, yeah, G is a good one. Okay, so the sum from k equals 1 to 50. K squared over 25. So what I would do with this, and you don't have to write it out, but you can kind of think it in your head if you want to. Um, that 25 in the denominator sometimes just throws people and they're like, oh my gosh, what do I do with that? Well, it's still a constant, so you can just pull it out to the front. And whether it's a fraction out there or a whole number, positive, negative, it doesn't really matter. You can still pull it out. So you can pull off that 1/25 out to the front of the sum, and then you use the formula from there.
Okay.
So we'll have the 1/25 out there, and then the formula to sum up k squared. Do you remember what it is?
I do not.
Alicia, do you remember?
No. I'm trying to do B. I'm confused on B.
Okay, we can get to B after this one. So for K squared, so just FYI, those are on page 4 of your chapter 12 notes. So it would be K times K plus 1 times 2K plus 1 all over 6. So the K is just going to be, or actually, I think I used the wrong letter. It's supposed to be is. So your N is just whatever your top number is up here. So for us, that would be 50. 50 plus 1 is just 51. 2 times 50 is 100. 100 plus 1 is 101. And then it's all over 6. And this is where I see a lot of other people doing a lot of unnecessary math. And so what a lot of people want to do is they just want to multiply the entire top out, multiply the entire denominator out, and then they try to divide these massive numbers into each other, which is totally fine. You can totally do it that way. It is not wrong, but it's not the best way. So what I would do is I would start simplifying the fraction. Like I would start to cancel stuff out if I could. So that way your numbers aren't as small. So like, for example, 25 goes into 50 twice. And then your 2 can go into the 6 3 times. And then the 3 can go into the 51. Seventeen times. And so now instead of having to multiply 50 times 51 times 101, now you can just do the 17 times the 101, which is a whole lot faster and a whole lot easier to do. So if you multiply this out, would you set up something like this? Would you go like 101 times 17 and then do it that way?
Yeah.
Okay. And that's totally fine too, but something else that might be a little faster is to split the 101. What is that doing? So you can write it as 100 plus 1 and then just distribute.
Gotcha.
So do the 17 times 100, then do the 17 times 1, and then add them together. And again, it's not something that you have to do. It's just a time saver if you can.
Definitely, yeah.
Yeah, and a time saver if you understand it. If you don't understand it, then don't use it. Just go back to doing the long multiplication out. Okay, so does that make sense?
Yeah. Makes a lot of
Okay.
sense. Thank you.
Yeah. Okay, and then the other one was 17 or 11B, right? The one with
I
the sign.
figured it out. I figured it out. If Braden has any more questions, I'm good.
Okay. Yeah, B is yeah, you just plug in those numbers and then evaluate sine of whatever. Any of the other ones in there?
I have like a general question. How long is like the exam supposed to take? Like, is this one longer than the last one, or is it like the same?
It's it's about the same as far as the time. The number, like the amount of questions in there might be a little different. But as far as time, like I try to write an exam so it would take an average of like an hour to like an hour and 20 minutes, somewhere around in there. As an average, but you still have the whole class time to do it.
Okay.
So you still have what, 10:30 to 12:50 about, maybe 10:40 once we get started and go through the instructions and stuff.
Okay.
So you have, I'd say you'd have close to about 2 hours and 10 minutes to do it.
I feel like this stuff's easier than last chapter.
I would agree with that. I think the more difficult stuff is kind of in the middle of the, like, of all the material.
Hmm.
And then the easier stuff is on the ends. It's like the first couple of chapters weren't so bad, and then the last few chapters aren't so bad, but the ones in the middle, there's a lot of content in there. And also this exam covers less material. Like there's only 3 chapters involved as opposed to like maybe 4 or 5.
Yeah, I think last exam, like we were on that section for like 2 months or something like that. It was just a heavy section,
Yeah,
heavy.
yeah, there's a lot of stuff in there. But that's the other thing to it, is like there was a lot of stuff in there, but supposedly everyone in this class got through trig, so it's not something that should have been totally new either. Supposedly it happens. All right. How are you two on the parametric equations, like where you have to graph them? Like where it gives you an x and a y equation, and then you have to graph it, label the intercepts, and then the orientation. Like, are those going okay?
Is that like question 9?
That would be like question 7.
Oh. Oh yeah, I had one question. So I know that for the quiz that we took, like concerning this part, I was supposed to erase one side. How would I know, like for next time,
Oh,
to erase that side or not erase that side?
okay, that's a good question. So what was it? I think it was something like x is equal to the square root of t plus 4. And then y is equal to the absolute value of t.
Yeah, that sounds about right. I
Okay.
think it was something like that.
Yeah, I think so. That was one version. The other version, it was like or t plus 9 in there, but you do it the same way. So if you look at the functions the way that they're defined, like y equals an absolute value, so y is always positive. So when you go to graph it, that means you can't have anything below the x-axis. So your entire graph is going to have to be above the x axis. It could hit the x-axis, or because y is always positive, or it could also be 0. It just
Okay.
can't be negative. But if you look back on your x equation, the same thing is happening. Because when you square root any, any value, any number, it's always gonna come out as either 0 or as a positive.
Okay.
So it can't be negative. So when you go to graph that, the graph has to be to the right of the y-axis. So if it can only be above the x-axis and only to the right of the y-axis, that means your graph can only be in quadrant 1. Because that's the only quadrant that goes with both of those descriptions.
Okay. And then another thing would be like if, like obviously if it's saying that t is greater than 0. Like in 7b, it like says that. So then we know it can't be below the x-axis. Correct?
Let's see, it could. It just depends on what the functions are. So usually when they say t is greater than or equal to 0, it usually goes off of, well, it's doing one of two things. It's either trying to get you to realize that they're trying to get you to realize the domain of something, or they're just trying to make it so that your graph isn't huge. And so that's kind of what, in this case, that's what B is doing, because the domain for the x equation can be anything, is the same for the y, but they're just trying to restrict it so you're not graphing everywhere.
Okay.
So did you want to keep going with that quiz question?
No, I think I understood. I just didn't understand like when I
Like
would
why?
know to erase it. Yeah.
Okay.
Like on
Uh,
7b, I noticed on the study guide it doesn't go all the way down. It like stops. So I was just wondering.
let's see. Oh, for the key.
Mhm.
Yeah. Yeah, so since they restricted it to t is either positive or 0, that meant the same thing would be true for the y. And then for the x, it would have to be 1 or larger. So yeah, it couldn't go below the x-axis in that case,
Got it.
or to the left of 1.
Thank you.
Yeah. So let's just say for whatever reason, those restrictions still held. So like you figured out the x is greater than or equal to 1, and then y is greater than or equal to 0, but your equation was like y is equal to, oh, I don't know. Think of an example. uh let's just say it was that. So instead of ln of x, it was ln of x plus 1, but it still had all that criteria. That means your graph, instead of hitting the x-axis, would actually be up here and going off like that.
Oh, okay.
So
That
it still works because your graph is still greater than or equal to 0, so it's still above the x-axis, and it's also on the x's greater than or equal to 1. Okay, let's see, do you have any other questions or any, like, do you want to try more examples of those? Or any other questions from, those parametric equation graphs? If you mentioned number 9, that was, the projectile motion stuff. So you wouldn't necessarily have to graph those.
Yeah, I think I understood everything. I don't know if Bryn has any more questions, but I think as long as like the exam is like the study guide, I should be okay. I should be fine. Thank you.
You're welcome. So question number 8, the reason why that was in there was just to kind of help you remember how like the absolute value of a function works as far as its graph. So like you had a graph A, B, and C like normal, and then D, E, and F, it threw those absolute value bars on it. Just to help you remember like, oh yeah, that's what you do when those things are in there. So in case you see something like that, that's how you would attack it. So did the number 8 make sense as far as the graphs were concerned?
I think they make sense. Like I understand why they work like that. They just flip them, right?
Mm-hmm. Yeah, cool.
Okay, I'm gonna go. Have a nice day. Thank you.
Okay, you too.
Did you already go over number 9?
I didn't. All we did is just sort of talk about it, but we can
Okay.
do it.
Yeah, could we?
Yeah.
That'd be great. Thank you.
Okay, so he is standing on the edge of a 12-foot tall cliff. Throws a rock towards water, initial speed of 88 feet per second at an angle of 30 degrees. Find all that. Okay, so the first one's always going to be to find the parametric equations. Because if you don't find them, then you can't do anything else. So there are formulas to use for the X and also the Y. So do you remember what those formulas are?
I don't have them memorized, but I have them here. So
Okay,
for
perfect.
X, it would be V um uh underscore 0
Yeah,
cosine theta to times t.
okay. And then your Y at T.
Negative 1/2 G times T squared plus V underscore 0 sine theta T plus H.
Okay. So that V sub 0, do you remember what that was?
No.
So that's your initial velocity.
Okay.
And they'll have to tell you what that is. They're otherwise you don't know.
Right.
Can't do the rest of the problem. Your theta, that's your launch angle. Or what the angle you throw it, launch it, shoot it, whatever you do. And then the G, remember what that was?
Um, one of the length measurements, right?
That was actually gravity.
Oh,
So it's going to be one of two things. It's either going to be negative 9.8 or sorry, 9.8, or 32, depending on the units.
Okay.
And then the T is time, and then the other variable in there is H. Remember what that was? It was
No.
the initials. So that's your initial height.
Okay.
Okay. So for us, the initial speed was 88 feet per second. Your launch angle was 30 degrees. Gravity, since we're using feet per second, that means you're going to use the 32. If it was meters per second, then you would use 9.8.
Okay.
And then your initial height was 12. So now to get the equations, you just plug in those four numbers everywhere you see them and
Right.
simplify if you can. So we have 88 cosine of 30 times t. Cosine of 30 is √3/2. So your x equation is 44√3 times t. And then your y equation, just start plugging those in too. So 32. And then 88 sine of 30 times t, and then the h was 12. Okay, so -1/2 times 32 is -16. What sine of 30 degrees?
1/2.
Yep, times 88 would be 44. Plus 12, so there's your y equation. So the rest of it, B, C, D, and E, are all dependent on those two equations. So let's say, for example, those two equations are wrong. That means that every other question that uses them is going to be wrong as well. But if you use the equations correctly, like I'll still give you credit for it. Like I'm not going to ding you twice for the same mistake over and over and over again.
Okay.
So let's just say that you totally forgot how to get the equations, but you know how to use them.
Mhm.
Then what I would do is I would make up an equation for X and for Y and try to relate it to the data somehow. So that way you still have equations in there and you can still demonstrate you know how to use them. Does that make sense?
Yeah, okay.
Yeah. Because if you can use them correctly, then it's like you demonstrated the skill for the rest of the problem, and you only lose like maybe 2 points as opposed to 10. If you
Right.
just whole thing blank because you couldn't do part A.
Gotcha. Okay.
All right, so B, how long is the rock in the air? You're gonna take your Y equation and you're gonna set it. Oh, whoops. Wow, I got ahead of myself. There we go. So you still are going to take the y equation. The x equation is only going to be used for part E. The x equation only deals with like how far out you throw something, like your horizontal distance. Everything else that's dealing with a vertical distance or a vertical situation is always going to go off the y. And so that's the equation you use most often. So
Okay.
you can take your y equation, set it equal to 0, and then solve for time. And we did this in class, but it's not something that you absolutely have to do. But if there's a number that goes into all three of those, I would just go ahead and divide it out. So like you
Okay.
could divide all three numbers by -4. And now it's just easier to either factor or use the quadratic formula. So it's going to factor into 4t plus 1. Oops. And then t minus 3. So you're going to get two time values. For the first one's -1/4, and then the second one is 3. So you want to go with the positive answer. So 3 seconds.
Okay.
All right, part C, when is it at its maximum height? You can do one of two things. And for me, the easiest one is to go off your answer from part B and just average the 2 times. Because when you throw something like this, when you throw something up or you launch it, it's making a parabola. It's doing something like that. So your time or your max height is going to be in the middle of the two x-intercepts. So if you just
Right,
average your
okay.
2 times, that'll tell you where it is in the middle. So 11/8 seconds. If you don't remember that, that's totally fine. You can also use -b/2a. And it would give you the exact same thing.
Okay.
For D, what is the maximum height? Now you're going to take the time you got from part C. Stick it into the equation. And go back to the original, not the one that you reduced. And then just evaluate that. So I'll leave that to you. So I've got another review session to go to. A little
Okay.
late. That's all right. So then for E, how far out from the cliff? You're going to take that same, or now you're going to take the time it's in the air, so the 3. And now you're going to stick it into the X equation. And that's usually the easiest one of the two equations to work with. And then you just leave it as 132.3 feet.
Okay.
And there you go.
Sweet. Thank you very much.
You're welcome. All right. Well, if you have any other questions, let me know. Otherwise, I got to get going.
Okay. Yeah, I think I'm good for now. Thank you.
Okay. All right. You're welcome. See you tomorrow.
All right. See you tomorrow.